In this review problem, we'll start looking at intervals of convergence for power series. And typically, we will use the ratio test to determine where the series converges absolutely. So here is a series, and this is a pretty complicated series. And the question isn't even what is the series, doesn't simplify to something that's simple, but is there an answer in the first place? If I take enough terms, if I use a computer to evaluate this, will this converge to something if I take enough terms? All right, so the way to go about this is to look at the ratio test. And so we will compute the limit as n goes to infinity of this big fraction. The denominator will be the original thing there, 2 to the n times n factorial x to the n over 2n plus 1 factorial. The numerator will be the same thing, except everywhere I see an n, I'll replace by n plus 1. n plus 1 factorial x to the n plus 1 divided by 2 times n plus 1 plus an extra 1 factorial. And so I will figure this out in absolute value, and I want to figure out for which values of x is this less than 1. For which values of x is this less than 1? So limit as n goes to infinity. All right, let's try to make this a little bit simpler. So I have 2 to the n plus 1, n plus 1 factorial, x to the n plus 1. In the denominator, I have 2n plus 3 factorial. Then I multiply by the reciprocal here, 2n plus 1 factorial, and then 2 to the n, n factorial, x to the n. All right, lots of stuff cancels. So we'll get 2 here. N plus 1 factorial over n factorial is n plus 1. Okay, here we have x to the n x to the n plus 1 divided by x to the n gives me x on top. And then in the denominator, I have, this is 2n plus 1, this is 2n plus 3, so I have 2 extra terms on the bottom, 2n plus 2 and 2n plus 3. Okay, now this is, well, I can make one simplification here. Those cancel, so I get the limit as n goes to infinity of x over 2n plus 3. But even if they didn't cancel perfectly, the degree of the new denominator is this is quadratic in n. This is only linear in n. So I know full well by L'Hopital's rule that this is going to go to 0 as n goes to infinity. And if 0, of course, is always less than 1 for all x. And therefore, we conclude that the series converges absolutely for all x. So this is equal to this number 0. This number is obviously always less than 1, and therefore it must converge absolutely for all x.